We are starting 13.1, which is graphing linear equations. The first half of chapter 13 reviews topics related to graphing that we have already done so far this year in 7th grade. So today we're going to be looking at linear equations. Linear equations are equations whose graph are a line. Any point that's on that line is called a solution of the equation. You can use the graph to show the solutions of a linear equation. This particular graph and table show the equation y equals x plus 1. To graph today, we're going to learn different types of strategies for graphing. But for today, we're going to be using tables similar to the one in this picture to generate some points, some ordered pairs, and then we're going to be plotting those ordered pairs onto our graph. So let's take a look at our first problem. It says graph y equals negative 2x plus 1. So looking at that equation, I know it's linear. It doesn't have any exponents on either the y or the x. As long as you have a regular y and a regular x, you're going to have a graph that's a straight line. So as we're doing our work today, if you have something that's not a straight line and you have no exponents, then there's a mistake in there somewhere. All right, so let's take a look at how we're actually going to solve it. When we do our graphs for this chapter, when we're doing them with the table, I'm going to ask you to pick 5 different points to put on your graph. The more points you pick, the more options you have to catch any errors you might be making. I also would like you to do at least 2 negative, at least 2 positive. So the points I chose for x, and really you could choose anything, but I chose negative 2, negative 1, 0, 1, and 2. So that's my column right here. Then I needed to choose some values or figure out the values for y. So I took my x values and I put them into the equation. So for example, x is negative 2. I put in negative 2 for x. Negative 2 times negative 2 is 4, positive 4, plus 1 is 5. Then I put in negative 1 for x. Negative 2 times negative 1 is a positive 2, plus 1 equals 3. So that's where the y equals 3 came from. For 0, I put in 0. Negative 2 times 0 is 0, plus 1 is 1. That's where the 1 came from. But then I did 1. Negative 2 times 1 is negative 2. And then negative 2 plus 1 is negative 1. And then finally I put in 2. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So then I have my ordered pair. So my first ordered pair was negative 2, positive 5. So I went over to this graph. I went negative 2 for my x value, so over negative 2 to the left, and then up 5 made my ordered pair. Then I did negative 1, positive 3, so over negative 1, up 3. 0, 1, so I went over 0, up 1, made my point. 1, negative 1, I went over 1, down 1, made my point. And then 2, negative 3, I went over 2, down negative 3, made my point. And then I connected them with a line. Just like when we were graphing lines earlier in the year when we were looking at proportional relationships, I want you to graph straight lines with arrows on both ends, unless it's a story problem where arrows on both ends don't make sense. And we are going to extend it through the entire space of the graph. So you can see how my line goes all the way through the entire graph. Okay, so here are 2 problems for you to try. I already got the table set up for you and I gave you values for x to use. You might notice that in problem 2, I gave you values of x that are a little bit larger than what we did in our last example. That's because I have a coefficient of negative 1/2 with my x. And because I know that I'm going to have to divide by negative 2, because negative half means the same thing as dividing by negative 2, I picked numbers for x that were easy to divide by 2. So you're going to go ahead and pause the video. You're going to make tables of your own, and then you're going to graph your points either on a piece of notebook paper or you can graph your points online. Go ahead and pause the video and take a minute to try these 2 problems. Okay, let's go ahead and check to see if your answers are correct. All right, so for number 1, y equals 3x. When I did 3 times each of my x values, I got negative 2, negative 6, negative 1, negative 3, 0, 0, 1, 3, and 2, 6. I plotted those points. Here's what my line looks like. All right, for number 2, I have the equation y equals -1/2 x plus 2. So my ordered pairs are -4, 4, -2, 3, 0, 2, 2, 1, and 4, 0. So to get those values, I'm going to go through a couple just in case you're confused by the fraction. -4, if I put that in here, -1/2 times -4 is like -4 divided by -2. That's going to give me a value of +2, and then +2 gives me the 4. That's here my answer. -2 times -1/2, that's like -2 divided by -2, that's a +1. +2 is going to give you a +3, and so on. That's what I did for the rest of these points. I put them on my graph. I connected them with a line that goes through the whole graph space and has arrows on each end. Okay, so let's look at these next 2 types of problems. So our next key idea is looking at graphs where we have horizontal or vertical lines. So the graph of y equals b, which is this graph over here on the left, is a horizontal line passing through the point 0, b. When I'm looking at the points there, our y points will be the same. That's what's giving me that 0 slope, that it's just a straight line horizontally. Every point that goes on there, that y value will be the same. And then the second one is kind of the opposite. It's a vertical line. This one over here where it says graph of x equals a is a vertical line passing through a0. So for vertical lines, you'll notice that all of the ordered pairs are going to have the same x value. And when you have the same x value, you're going to have them all line up so that they're vertical. That's going to give you an undefined slope if you think back to when we did slope in chapter 5. So let's take a look at 2 graphs that give us horizontal and vertical lines. So for A, it says y equals -3. They didn't give us any points for x. They didn't tell us anything about the value for x, and that's because for this equation, the value of x doesn't matter. It's just that y equals -3. So I can pick any values that I want for x. I chose -1, 0, and 1. I didn't do 5 points for this one just because it's one that is going to give me just a horizontal or vertical line. For these ones, you can just pick 3 if you want. Every single one's going to have y equals -3, and that's because my equation is y equals -3. No matter what I pick for x, I'm going to have that same y value. So here, I've got my same y values. I put them on here. I've got a horizontal line that hits the y-axis at -3. And then bx equals -2. That means it doesn't matter what you put in for y. Your x values are always going to be 2. So I have 2, -1, 2, 0, 2, 1. You can pick whatever you want. Again, because it's going to be just a vertical line graph, you can just pick 3 points. So then I plotted those points. I connected them. They gave me a vertical line because my x values in those order pairs are the same. All right, go ahead and take a moment to pause the video and try these next 2 problems. All right, let's go ahead and check your answers. Okay, so I didn't write down my tables for these ones, but here's what your graph should look like. X equals -4 means you start at -4 on the x-axis, and then it is a vertical line that goes up and down. Y equals -1.5, you go to -1.5 on the y-axis, and then you're going to make a horizontal line. Okay, let's take a look at this next one. So it says the wind speed y in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. So story problem situation, remember when we do graphs for those, usually it's just a 1-quadrant graph, which is what this one is, that you have the x and y axis here on the side. When we graph our equation, we need to make sure we have labels on our x and y axes. We have a title on the top. The strategy for graphing is going to be the same as what we did in example 1, where we set up a table and we solved for some points to go onto the graph. So I'm going to go ahead and show you what my finished graph looks like. All right, so there's a lot written on this slide here, but I've got my title up top here. Wind speed is what I chose. That should come from your story problem, your title. So I know it's about wind speed. I know hours is going to go on the bottom. They tell me that directly in the story problem, that X is the number of hours, so that goes on the X-axis. And then they tell me the Y is miles per hour, so I abbreviated MPH, I put that on the Y-axis. Negative points don't make sense for this particular one because I'm not going to have a negative amount of hours after the storm enters. So that's not going to make sense to have negative numbers. So I chose 5 points, but I chose all positive points. So I started at X equals 0. I like 0 because it's a pretty easy number to put in an equation. And then I just went up 5 numbers from there, 1, 2, 3, 4. So I put each one into my equation. So 2 times 0, I'm using this equation right here. 2 times 0 plus 66 gives me 66. Now you'll notice over here in my graph, I did a little squiggly line in between 0 and the value 65. If you are not doing an equal interval from your 0 to your first point on your graph or your first number on the axis, you do need a little break there to indicate that you have skipped some numbers. And then from wherever you are, you need to make sure you're numbering evenly. I chose to number by 5s on my y-axis, and I chose to write 1s for every 3 lines on my x-axis. Make sure those intervals are equal, both in number value, here, those are 1s, and space value. I went up by 3 spaces each time. Otherwise, your graphs are not going to look linear, even though they should be a line, because there's no exponents on our y and our x. Okay, so I went through, I got my points. X is 1, y is 68. That came from 2 times 1 plus 66. So 2 times 1 is 2 plus 66 is 68, and so on. I got my table points. I plotted them. This time I only put an arrow going in one direction, again, because negative values don't make sense for the story problem. And then for part B, it says, when does the storm become a hurricane? And I already have my answer there, 4 hours. Here's where that came from. So if I look down at the 4 and I look to see where it hit, it tells me down here in the story problem underneath the picture, which I didn't read to you, I should have. It says a tropical storm becomes a hurricane when the wind speeds are at least 74 miles per hour. So I can see at 4 hours, that's where it's going to be 74 miles per hour. When I went up to 4, that's where the 74 was. That tells me that information, that the storm becomes a hurricane at 4 hours. All right, let's take a look at this next problem. What if the wind speed of the storm is y equals 1.5 x plus 62? When does the storm become a hurricane? So you're going to go ahead and do the same things that we did in the last problem. You're going to set up your own graph. You're going to want to make sure you put labels on it. You're going to set up a table with 5 points. You're going to solve that, and then you'll look to see where it becomes a hurricane. Go ahead and pause the video and try this one on your own. Okay, so I've got my graph set up here. I actually don't have the whole thing finished, but there's enough here for you to get a sense of what you should have. So here I have 1.5. I chose to go by multiples of 2 on my x-axis. So 0, 2, 4, 6, 8. That, because I did multiples of 2, when I multiply by 1.5, I get whole numbers. And I don't have to deal with plotting decimals. You certainly can do decimals. It doesn't really matter. But I chose multiples of 2 because I have this 0.5 as part of my number. So 1.5 times 2, and then that's going to give me 3. And then plus 62 gives me that 65. And then here, if I do 1.5 times 4, that gives me 6, plus 62 gives me 68, and so on. So once I fill in my table, I see at 8 hours, that's going to be 74. And I do need to make sure that I have labels hours, miles per hour, and a title wind speed on my graph. All right, so our last one for today, explain how you know if an equation is linear. Go ahead and pause the video and write down your answer. All right, let's see if you're correct. So if you know there's the way to know before you start if the equation is linear is checking for exponents. If there are no exponents on either the x or y value, it is linear. The other way to check is to graph it and see if it's a straight line. So if you put if it's a straight line when graphed, that's also a correct answer for this one. Both of those are ways to know if it's linear. Looking for exponents will tell you before you graph if it's linear. Looking at your final graph after you've graphed is another way to see if it's linear.